Welcome guys to a new lesson for Embergen introduction tutorial series. Last time we tried to work on something more complex. We created something related to cloud setup. It is time to continue working on something like that. So actual plan is to play with clouds for this lesson and maybe also lesson 6, and then we'll have some lessons about pyro effects. So we'll play with fire, smoke and explosion. That's the actual plan. So last time we created the simulation, it was really simple, but the emitter is not so complex because we created everything using the torus. So let's get to open the old project. Last time we created this one. Let's double check if everything is still working perfectly. So we have to zoom back because we are really near the volume. That's the simulation. It is better to work with a lower resolution to be faster because we have to take care about the emitter shape. So let's go back to have the right minimum bounds for all axes, and we go lower with the voxel size to have something more simple to be simulated. So let's go to apply and then back to the simulation. So let's go to play, and you see that that's really fast, and the quality is still high to be able to see something. So last time we had just a really simple emitter. It was created using, let's go to have also the bounds in the viewport. So we'll try to create a shape inside the bounds that will be nice to have for cloud. So this one is disconnected and we have no activity for this shape. So let's go to create a new primitive. So we will try to use something we done in the first lesson. We talked about the shaping. So we will try to create something more complex using more shapes. So that's the first one. We are going step by step to connect the primitive and the shape to know how it is working. So we say that we like to see the emitter, so we like to have it visible, so show emitter. Then we go to connect, and we have essentially a sphere. So again, something really basic, but I like to create the shape using more emitter. First of all, we need a little bit more space over the z-axis because we have to have more space for the new shape. So let's go to create a new one. We're going to use a blend, so we use more shape to create a new shape. So the blend is connected now with a primitive emitter, and we go to create a new node, a copy essentially. So that's the shape B. Actually it's the same, so we go to change. Let's go for example for capsule. We can use the capsule over another axis, so we can rotate, or maybe we can change the radius and the length, but maybe the best way is to use an ellipsoid because it's more similar to what I'm trying to achieve. Obviously that's just an example. You can create everything you like using this technique, and you can create the shape you like. It's not so complex to be used. So I like to have a smooth union, so the button is smooth, so the shape will be really nice. Let's go to have a new blend. The second blend now will be connected to the emitter, so we are going to blend another shape inside the the blend, the new blend node. So second one, just to make an example, can be a sphere. We go to change the scaling and then we can move it, for example, there, and just a little bit up with the over the y-axis, and maybe some tweaks to the scaling. So in this way the shape is a little bit more complex than before, so more chaotic shape will give us a better result. Okay, nice. Let's move forward with a new shape. We got to have a new shape inside the blend, so let's connect this one, let's disconnect this one, and then back to the shape. Okay, nice. Second sphere, we go to move it. Let's go, for example, there. Let's think about it just as a basic technique to achieve complex shape. So it's not the only one, it's not the best one, so it's just to give you a rough idea about what I have in my mind. In other software, for example, we can use a sphere scatter over other sphere to create a cloud, or we can use a noisy mesh. So there are many ways to create something like that. By the way, a new blend with a new primitive inside. Let's connect to the shape, and then we get to move this new sphere. We can go to have it there and just make some tweaks. So you see we have some bigger areas and some more smoother areas over the shape we are creating. And then now we can use a new blend. We go to copy the primitive, disconnect this one and connect the new one, and then the new sphere can stay, for example, up there, just a little bit more little. Nice. So we can imagine to have it, for example, in another place. It's not a problem because, you know, over the top we have not so much space, but we can always change the bounding dimension. Okay, so the basic shape is done. Something that can be interesting is to, if we like to have a flat area on the bottom, you see that it's really nice. It is behaving like a cloud because the shape is more similar to a cloud. So in this way you can imagine how much it can help. For example, it can be useful to have maybe a shape on this side. So let's go back to the blend shape. I like to have back the visibility of the emitter, and then we go to have a new blend. So this one is connected there, and again we have a copy of this sphere is connected there as a shape P, and then the blend is connected to the emitter. Okay, the sphere can be moved on the back area. Okay, and then we can change the scaling. So the shape is a little bit different over this area on the back. We can remove the shape, and then if we go to play, okay, that's nice because you see, again, sorry, you see that we have something that is coming out on this back area. So it's nice. I am loving it. It's really nice. So we can save this new setup because it's a basic setup that works really nicely. So we have just to understand how to play with it in the next part to make the animation. By the way, if we like to take care about the to flatter the bottom area, we have two ways. For example, just two examples to do it. So one is done using the you see, that's nice because we have a little piece of cloud that's disconnected, and we have a lot of details over there. So that's really nice. I mean, and also the density is nice because we have some denser area and some areas with less density. By the way, it is interesting to work on the flatten area. We have the possibility to do it inside the volume. So you see that we have the Z ground effect. So you see that we can rise up this one, and then we can have the width that is going to have something like a bias, like a gradient. And in this way, we are removing partially the volume on the bottom, and in this way, we are in any way flattering the area. And that's the way we have more parameters here, so we can imagine different ways to do it. By the way, another example can be done using the blending, because we can use a subtraction. So we can subtract something over the bottom to have a flatter, a flat emitter. And in this way, we are going to have something that is flatter than before. Okay, let's move this one here, and connection, then remove the connection with this one, and then back with the connectivity. Okay, so the second shape, let's give us a little bit more space. Okay, nice. The second shape can be something like a flat shape, so maybe a rounded box is nice enough. We like to move it in the center, and we have to scale it and then move it down to go and change the actual shaping. So we can play with a smooth union, and we change to smooth subtraction. So you see that now we are removing some parts to the emitter, so the shape will be a little bit more flat. So we can still play with the values there to find the best compromise. By the way, let's remove the emitter, and you see that the bottom area is a little bit flatter than before. That's just an example, so don't worry about it. It's just a way to create something like that. But it is nice to see that we have some tricks to play with the volume. Okay, so cloud is really nice, as I thought. So we have the simulation that can be, maybe this frame is not bad. Maybe we can imagine that this one is our hero frame, because it's nice. So we have just to select the final resolution, and then we are able to export everything. So let's go to take care about the resolution. That's nice. Apply. Then we have enough memory. Maybe we are using a lot of memory, so maybe I have to take care about it, because I'm not sure we have enough memory to play with the software. So you see that it's taking really a lot of time to prepare the you see that it has some kind of problem that we are using too much memory. So we have or we have to scale the voxel size, or we have to scale the volume or the bounding box, because it is using too much memory based on my GPU. So we have to take care about it. The resolution is really nice, but it is really complex to use it. So I take care about the voxel size. So in this way, we should have a little bit lower resolution, but a little bit more memory. So you see that the software is more responsive and everything is working fine. And I had to take care about the bound too. So you can have the necessity to do this kind of adjustment. So for our test purpose, the resolution is enough, so it's not a big problem. So we can save the project and then we can move forward. So we're going to export the cloud. So the idea is to export this one. Let's call it cloud test. We go to export essentially from frame 0 to 60. So then we can use the frame we like. By the way, we can have all 60 frames to the side, which is the best. We have no flames, so we can remove it because we need essentially the density, because we don't need anything more to merge in other software and render it. So about the axis, we are moving to various axes. Embergen is Z up, 3ds Max is Z up, other software are Y up. So we can live in this way, and in the 3D part software we are moving. Maybe we can make a rotation to fix the position and translation and rotation, so it's not a problem also because we can have some kind of scaling problem. So let's go to export. So actually it is starting to prepare the simulation. It will simulate and export everything, so it is just a little bit slower than before because it is saving also the file. So now we are in 3ds Max. Today we are going to use 3ds Max and Houdini, but there are many ways and many 3D software to work with. We have the possibility in 3ds Max to use Arnold with volume rendering. But usually we can say that V-Ray is maybe the most used 3D rendering software for rendering engine for 3ds Max. So we are going to use V-Ray to make a test. So obviously it's not a tutorial about cloud rendering with V-Ray, it's just a test. So we can use the V-Ray volume object to load our cache. Let's go to select the first frame. Okay, it is asking for a preset because it can set the volume based on the software that created the volume at the beginning. We have no Embergen preset, so we can say no preset, and we are going to use the manual configuration. Okay, that's our volume. So you see that's visualization, a really fast visualization. So it is not shading the volume. It can do it, but this one is really fast. So I think we can use this one. So it is really similar. We have no problem with the rotation because we have the same axis configuration in 3ds Max and Embergen. Now we go to set the lighting. We'll do something really simple. So we'll have essentially a V-Ray sun, that's a direct lighting. But before we go to create a V-Ray light, you have the dome light. Okay. We go to take care about the multiplier. We are not using the color management, so we go for multiplier set to 1, so we are setting everything manually. Let's go to have an HDR map to be used with a light. I'm going to use the map. Maybe let's see, the usual map I'm going to use is the one I created for another course with Embergen. Let's remove the preview to be faster and open. Okay, that's done. We have the basic illumination done with the sliding. So we can set the rendering, say that we like to render with V-Ray, and then let's wait for the update, and then we are ready. We can choose another configuration there for preset for the resolution, and then let's double check something. Okay, let's do a render. Maybe before we go to have a new light, so let's add the V-Ray sun. I like to add before some rotation to have essentially a similar orientation for the sun based on the texture I'm using. Also there, the multiplier needs to be taken down because we are not using the color management, so it needs to be lower. Okay, and render, and that's what is going to render. So we have to take care about the lighting for sure. Volume are slow to be rendered, so it needs time and it needs love. Let's go to color mode direct, so it will go to use the color, the filter color as the light color, so it's the best way in this case. Okay, we have really low lighting, so we need more light for sure. Okay. I'm not going to have the real-time rendering with a real-time update just to be sure that it is more responsive. So we go to have this render area, and then we can take care about the rendering intensity multiplier for the light. So in this way we are sure that we have the right power and energy for this light. So okay, it is better. It is better for sure because we have more lighting. We can have a little bit more, and let's go back to the dome. So we'll see also the environment lighting if it's enough or not. Okay, it is not bad, not bad. By the way, we can take care about the shading there in the rendering. For the volume, we have the possibility to control the color, the density, and stuff like that. So first one is the color, the custom color. We can go for a brighter gray, or maybe similar to a white, maybe not completely white, because we can burn really fast the color because we have to take care again about our lighting. So we have to find the best compromise between the cloud color and the light. So back to the preview. Okay, that's a little bit better. We can have a little bit of burning, but it needs to be not so much. Okay. Let's go to bucket, and maybe we can set a little bit higher the noise threshold to see maybe the quality to understand how it is moving forward. Sampling is automatic, so we are not taking care about the rendering setup. We are not taking care about a lot of stuff, so don't worry about it. That's just an introduction to understand how the data simulated by Embergen can be used in other software. So let's wait for some bucket. The volume needs time. That's clear. So you need to be a little bit patient to wait for the volume rendering, but quality will be nice enough, I think, because volume is simulated in a really nice way, and Vray is really powerful to give us the possibility to achieve a really high quality result. Okay, so you see that it's moving forward. We have a little bit of burning over the top, so we can take care about it, but generally the quality is really high. So I think that you see without any big efforts we are creating something really really nice, I think. So you see that we have a lot of detail. Here we can take care about the color, so maybe we can go for something a little bit darker. Here the smoke opacity will give us the possibility to control the density, so we can have a different kind of look about our volume render. And we have other possibilities. We have the scattering, you see, we have the simulation for the scattering, or maybe you can have the retrace scattering. Actually, we have the approximation and the shadows. It's a nice way to have something faster. Ray traced is more precise. Here we have the possibility to control the light cache, speed up. So there we have the master multiplier. It's something like a multiplier about the color and the density there, so you can take care about different coloring. And then we have the scattering, a multiplier for the scattering inside, the external scattering, and you have the possibility to control the density of the shadows with the shadow strength. So again, we are not going in deep to see how it works in 3ds Max. Maybe in the future we can do something like that, maybe. By the way, actually it's just the way to think about it. So let's move to Houdini to do the same thing. So we go to import everything, and we use the mantra render, the internal rendering of Houdini to render the cloud. You can think about Houdini, maybe you can say, okay, Houdini is the most powerful software for visual effects, but you know, Embergen is really fast, so maybe it's a great solution also for Houdini artists. So let's create a new node, a geometry node. That's we can call it merge cloud VDB, and then we go to inside this node with a double click, and we have a file. Let's go to select the cache, this one. Okay, nice. And let's go at the frame we'd like to render. The visualization is really nice inside Houdini, because you see, we see essentially the cloud with the right shading, but the orientation is wrong, because in Houdini we have the Y up, so we have to use a transform node. With the transform we can translate, rotate, or scale a geometry or something, an object, you know. So let's call it fix, rotation, and scale. Then, you know, we are going to scaling, because the scaling is really big, and that's because we have it is 100 times bigger. That's a problem about the scaling in different software, but it's not a big pain. Let's remove the grid, and then we go to rotate minus 90 over the x-axis. So you see we have the same orientation we had in Embergen, and the scaling can be 001 will be the perfect one, but 01 can be nice because the scaling is interesting. Or maybe, okay, let's set to 0.01, because in this way we'll have the same rendering we had before. You see that now it's really little, because we are talking about meters, so the density is low. We have to take care about the density later in the rendering. Let's create a new camera. We lock the camera, so actually if we move the camera, it is connected to the viewport. A new light. We have an M light. This one is like the dome we created in 3ds Max before, and we get to choose for the same texture. So you see it works in the same way. Also there in Houdini we are not taking care about quality, sampling, and stuff like that. It's not the moment to work on something more complex. In the material palette we can choose the cloud shader. That's a shader ready to render clouds, but you know, there are many ways to do it. Then we have to assign the material directly in the render tab. and we are going to choose the cloud material. We can have a new light, so it is possible to simulate the sun as we done before. Okay, sun rotation needs to be tweaked, and also the intensity maybe. So rotation, I have some rotation that I created before. So we are talking about a position in the rotation that I wrote here over my notepad, and then, sorry, not inside the light. Just a little bit of higher sampling, but we should talk about the sampling. So for the moment, you know that you have the possibility to control the sampling quality. Okay. Then in the render view, if we click on rendering, we have the generation, and actually we have a progressive render done with mantra. A lot of grain, density is poor, and that's because, you know, the scaling is connected to the density. So we have to go inside the material, and we have a parameter, the cloud density. And cloud density is able to affect air density to the cloud. With 25, you see that we have a lot of density. That's really nice and more similar to the one we had inside Embergen and 3ds Max. Again, also there, it needs time simulated 50. Maybe the is better because it is going to be really nice. We have the shadow density multiplier, so we can have more or less density for the shadows, and then we have the scattering phase to have more back scattering or front scattering. So the default value is essentially really good for cloud rendering, so we can live in this way without any problem. You have the cloud color. With the cloud color, obviously you can take care about the coloring of the cloud. Is the same we done in 3ds Max with Vray. Now something related to the rendering. We move to the physically based rendering, just because it's the best one. It is a PBR render. About the quality, pixel sample can control globally the quality, and 6.6 can be enough. We should work more on the anti-alias and sampling setup, but you know, we are not taking time to talk about mantra, so it is better to play more just with the global parameters. Inside the limits, if we say that we have 50 limits for the volume, we have more bouncing inside the volume rendering. 50 maybe it's too much because, you know, everything is too bright, but having a little bit higher volume limits can give us an higher quality for our rendering. You see that obviously everything works together with the cloud color and the cloud density. Everything is connected, so you have to find the best compromise. Let's change a little bit the color there, and then again we can have the possibility to control the cloud density again to maybe 40, so you see that cloud is more dense, and I love how it is going to be rendered. Actually it is using the progressive, but clicking over here it is changed to a bucket render. So that's the rendering. It took a little bit of time because, you know, again, volume rendering is really slow, but the quality we are achieving is really nice. We have a lot of detail, The volume is really nice, lighting is working perfectly. So I think that's really amazing, and we've done everything with no time. We are talking about seconds. So that's a new step in cloud rendering and simulation with Embergen. We can move forward. In the next part we are going to talk about bigger clouds, so maybe cloudscapes, and we are talking about animated clouds. So guys, thanks for watching, and we'll see more soon. Bye bye.